Hello everyone, I welcome you all to Statup Academy, your online gateway to success in ISS exam. This academy is exclusively for ISS exam. We are focusing on ISS 2026 and we have been covering the third paper, which is considered as the most difficult paper of the statistics. And today we have covered till now we have covered econometrics line by line according to the syllabus given in the notification by UPSC. And today we will cover the topic sampling. Yesterday I gave you an overview what is sampling and all the basic things that we should know of sampling. Today we will continue forward what is sampling, and today we will continue the estimation of sampling and everything after that. So let us begin. So what is we have yesterday we have done what is sampling, and we have done what is probability sampling, and two of these probability sampling, simple random sampling with replacement and simple random sampling without replacement. Now for estimating the mean and the variance of simple random sampling with replacement and without replacement, we first need to specify the notation. It is very important to specify the notation before we derive any part which has been asked in the question, because how would the examiner know what is meant by small y, what is meant by capital Y, what is I, and all those things. So before beginning of any derivation in any question of the examination, you should first write the notations, and then after that we will begin giving our answers. So first of all we will derive notations, not derive, tell. Notations. So first notation is population mean. It is given by capital Y bar, which is nothing but 1 upon capital N summation I goes from 1 to capital N yi. Then second one is sample mean. Small y bar is equals to 1 upon small n summation I goes from 1 to small n y small yi. Then third one is population variance. What is population variance? We denoted by sigma square, which is nothing but 1 upon capital N summation I goes from 1 to capital N yi minus y bar whole square. Or simply we can write capital S square. There are two population variance. We'll know what are we talking about according to simple random sampling with replacement and simple random sampling without replacement. And we are deriving both simultaneously, so you know the difference between both of them and the similarity between both of them. So it will be I goes from 1 to capital N yi minus y bar whole square. Now the fourth denotation is sample mean. Sample variance, sorry. It is given by small s square, which is 1 upon small n minus 1 summation I goes from 1 to small n yi minus y bar whole square. Fifth one is population total. We can write P T, which is given by summation I goes from 1 to capital N yi, or simply N y bar. which has been taken from mean, obviously. And the sixth one is sample total, which is ST, given by summation I goes from 1 to small n, yi is equals to small n y bar. So these are the six denotions or notations that we will define before estimating. Now I will be telling you two three rules of so that you don't get confused. What are we doing in the derivation? So the first rule is whenever any point, suppose yi, follows any distribution independently, follows any distribution with probability pi, then we can say that estimation of yi is nothing but summation I goes from 1 to n, where I goes from 1 to capital N, yi pi, or we can say this is equals to, let us suppose, theta. Now estimation of ai yi is equals to, ai comes out of estimation and we are left with estimation of yi, which is nothing but ai summation I goes from 1 to n yi pi, which is nothing but ai theta. And similarly, if we say that the variance of yi, let us suppose, is sigma square, then variance of ai yi will be nothing but, ai comes out of it because it is a constant, square of ai will come out of it because it is variance. So variance of yi is left, and variance of yi is nothing but sigma square ai square. So these were the three rules that we will consider before the derivation. Now we will start estimation. So first is in SRSWR, simple random sampling with replacement. We are deriving estimation of sample mean. We all know that what is sample mean, small y bar. So we can write it here also, small y bar. So estimation of small y bar. Here we are checking whether the sample mean, the sample which we have taken out, and the mean which we are calculating for that sample is actually derived from the population or not. If it is derived from the population, then it will be an unbiased estimator of sample population mean, and if it is not, then it will be a biased estimator, or it will not be an estimator of that. So we can write it as estimation of 1 upon n summation I goes from 1 to n yi. Now 1 upon n and summation can come out and estimation goes inside. It is 1 upon n summation I goes from 1 to n estimation of yi. Now estimation of yi, I have told you, is nothing but summation yi into pi, probability. So we can write it as 1 upon n summation I goes from 1 to n summation j goes from 1 to capital N yi into pi, probability of selecting the ith unit. Now in simple random sampling with replacement, the probability of selecting uh, ith unit is nothing but 1 upon capital N. So we can write it as 1 upon n summation I goes from 1 to small n summation j goes from 1 to capital N yi into 1 upon capital N. This derivation we have done yesterday in yesterday's lecture. If you have confusion, then you can rewatch that lecture video. So now here there is sorry, it is j. These are j. Here there is no I point, so I can write the summation directly. So it will be 1 upon n into n, 1 upon capital N, summation j goes from 1 to capital N, yj. These and n gets cancelled and we are left with this. It is nothing but capital Y bar. So Y bar, sample mean, is an unbiased estimator of population mean. And if we derive 4 in SRSWOR, simple random sampling without replacement, the same derivation will follow, because here also the probability of selecting jth unit or ith unit is nothing but 1 upon capital N. So both the derivation in simple random sampling with replacement and simple random sampling without replacement, estimation of sample mean is this only, which is sample mean is an unbiased estimator of population mean. Now moving on further, we will calculate what is the variance, estimation of variance. First of all, in SRSWR with replacement, estimation of sample variance. So we all know that variance of sample, we can write it as with replacement, is given by estimation of y bar minus estimation of y bar whole square. Now estimation of y bar we have derived here, it is nothing but capital Y bar. So it will be estimation of y bar minus capital Y bar whole square. Now y bar can be written as estimation of 1 upon n summation I goes from 1 to small n yi, and capital Y bar can be written as 1 upon n summation I goes from 1 to n y bar. Because there is no I term, so this summation will become n and n gets cancelled. So we can write capital Y bar as this as well, whole square. Now taking things common, 1 upon n summation I goes from 1 to small n yi minus capital Y bar whole square. Now here we can take 1 upon n outside and summation also outside. So it will be 1 upon n square summation I goes from 1 to small n estimation of yi minus capital Y bar whole square. Now this estimation, in the estimation chapter you must have read that estimation of yi minus y bar whole square is nothing but summation I goes from 1 to n yi minus y bar. Okay, let me write it. Estimation of yi minus y bar is nothing but, square is nothing but summation I goes from 1 to n yi minus y bar whole square plus summation I not equal to j goes from 1 to capital N yi minus y bar small n to yj minus 1. This is the formula that we can write. So writing, substituting this in here, variance of y bar wr with replacement r is nothing but 1 upon n square summation I goes from 1 to small n estimation of, okay, let us take summation also inside and keep estimation outside. So we are left with summation I goes from 1 to small n yi minus y bar whole square plus summation I not equals to j goes from 1 to small n yi minus y bar into yj minus y bar. Now taking in the estimation, we are left with 1 upon n square summation I goes from 1 to n estimation of yi minus y bar whole square plus summation I not equal to j goes from 1 to small n yi minus estimation yi minus y bar yj minus y bar. This is, let us consider this as equation number 1. So now this is nothing but the formula of R variance, sample variance or sigma square, we can write sigma square, and this is, okay, let us first P plus Q. Let us take it and solve simultaneously. So P is nothing but summation I goes from 1 to n estimation of yi minus y bar whole square. Now this estimation of yi minus y bar whole square is nothing but variance of y bar. So we can write it as summation I goes from 1 to n into sigma square. This can be written, and this can be n sigma square. First equation. Then Q. Summation I not equals to j goes from 1 to small n estimation of yi minus y bar into estimation of yj minus y bar. Since in simple random sampling with replacement, yi and yj are both independent of each other. Ith draw and jth draw are independent because we put back, if you remember the example, we put back the chits in the box and then we shuffle again and take out the chit. So the draw of first term and the draw of second term is independent of each other. So we can write estimation of yi by minus y bar and into estimation of yj minus y bar. It will be, this will be n into n minus 1, this summation, and this will be y bar minus y bar into y bar minus y bar, which is nothing but equal to 0. So our this becomes 1 upon n square into n sigma square, which can be also written as sigma square upon small n. Now sigma square is equal to capital N minus 1 upon capital N capital S square. So here, let us, this is equation 1. Here we can also write this as capital N minus 1 upon capital N and capital S square. So this is the variance of y bar, variance of estimation of variance of sample mean with in simple random sampling with replacement. Now moving on to simple random sampling without replacement. Let us take that equation 1 only. So variance of y bar in WOR without replacement is given by 1 upon n square summation I goes from 1 to n estimation of yi minus y bar whole square plus I not equal to j goes from 1 to capital N yi minus y bar. Okay, first take that only. small n estimation of yi minus y bar into yj minus y bar. So this is it. This is P and Q. P again is sigma square upon n. I am not solving it again. And Q, let us solve for Q. Is summation not equal to j goes from 1 to small n. Estimation of yi minus y bar into yj minus y bar. Let us consider this. So we know that estimation of yi minus y bar is nothing but equal to 0 because it is again mean deviation, a concept we did in econometrics. This is mean deviation, and we can write estimation of yi minus y bar whole square is nothing but summation I goes from 1 to n estimation of yi minus y bar whole square plus summation I not equal to j goes from 1 to n estimation of yi minus y bar yj minus y bar. Now this is equals to 0, the square also will be equal to 0. So if it is equal to 0, then we can say that summation I not equals to j goes from 1 to n estimation of yi minus y bar into yj minus y bar is nothing but minus summation I goes from 1 to n estimation of yi minus y bar whole square. So this is the value here. We can substitute the value of this here. So we will get estimation of yi minus y bar whole square ka estimation. Okay, so variance of y bar without replacement is nothing but 1 upon n square. First term p can be written as sigma square upon n, and this second term can be written as n minus 1 s square upon capital n minus 1. Here this term is n minus 1 into capital S square upon capital N. So we have substituted this, and this also has a minus sign, so we have put the minus sign here. Plus has been removed and minus has been included. Now we can take n common from here. This is n sigma square. So taking one n common, n upon n square, we are left with sigma square minus n minus 1 s square upon capital N. Sigma square can be substituted. Sigma square is nothing but capital N minus 1 upon capital N s square. So substituting this here only, we can write n minus 1 s square upon capital N. 1 n gets cancelled. So we are left with 1 upon n. Capital N can also be taken common, and s square can also be taken common. We are left with n minus 1 minus n plus 1. Minus 1 plus 1 gets cancelled, and we are left with n minus small n s square. So according to the estimation, variance of sample mean with replacement is nothing but n minus 1 upon n s square, and variance of sample mean without replacement is n minus small n upon n s square. These type of questions has been asked in PYQs a lot of time, then that derive the variance of sample mean and variance of with replacement and without replacement, state the positive and state the differentiation between both of them, and estimate the population mean and estimate the sample mean in simple random sampling with replacement and simple random sampling without replacement. So this will be your derivation for all the questions that have been asked according to this. We will cover some more topics, then we will cover the PYQ. I hope you understood what we have done today and keep on working hard on this along with us. And if you still have any doubts, you can ask in the comment section or on WhatsApp channel. Thank you.